All right, graph y greater than x squared plus 3x minus 4. Let's graph it. First off, do you actually know what shape it's going to be?
What?
It's going to be a parabola. Okay, it's not going to be lines, it's not going to be beads, parabola. It's in standard form. Tell me how to find something.
The vertex.
Find the vertex. How do you find the vertex?
Find x, which is negative b over 2a.
X squared to the vertex is opposite b over twice a.
So negative 3
Negative 3
over 2 times 1.
from 2 times 1. Negative 3 halves. Now that you have the x coordinate, how do you find the y coordinate?
Plug in there.
Plug it in for x. Square of 3 halves, 3 squared is 9, 2 squared is 4, you got a positive 9 quarters. 3 times negative 3 is negative 9, sitting pretty over 2, minus 4. You have to have in common to add 3 fractions together. Common denominator. What do you think the common denominator is going to be?
4.
It should be 4. So everything becomes over a 4. 9 quarters stays 9 quarters. What's 9 halves become? 18. If we double the 2, we double the 9. How about 4? We double the understood 1. Sorry, if we quadruple the understood 1, quadruple the 4. Do the easy math. You're in 5th grade when you like school. Maybe 25. Normally I don't do this, but we are graphing. What's that look like as a mixed number?
What would it be?
4.
How many times 4 is 25?
6.
6. The remainder of 1. Negative 6 1/4. Makes a little more sense. Negative 3 halves would be negative 1 1/2. Back unit and a half, down 6 1/4. If I had enough room, I would open hole this. You know why I would open hole it?
Because it's an inequality.
Because it's an inequality. But I don't count off for that. I count off for the dashes and solids. All right. What would you do from there?
Yeah. Find this.
There's 2 things that you can do. We're going to do them both. What's the initial slope?
1.
1. That is the initial slope.
Or
A value is 1 here, kids. The initial slope is 1. So I can rise 1 or run 1. I want to do something else too. This is actually the most important part about inequalities and quadratics.
Why?
Not the y-intercept. The x-intercepts. How do you find an x-intercept? 0 is x squared plus 3x minus 4. How do you find what x-intercept? You let y be 0. Always has been, always will be. What's your favorite F word? Don't say it, Chris. Factor.
Function.
Oh, yeah.
Factor is your favorite F word. Factor, x squared plus 3x minus 4. Come on, kids. Why can't anybody factor?
What? X plus 4, x minus 1?
Okay, thank you. In every country but America, they teach factoring in the 8th grade. Let you get a year older and get 9th grade. You guys got to skip it. Got to be even quicker now. Since that's how it looks factored, what are the x-intercepts?
Negative 4 and 1.
I'm actually going to write that out. A lot of you kids are writing on your quiz. You're writing, I don't know if you remember the problem or not, there's one of these where you had to find the x-intercepts, and you wrote them as a single ordered pair. There's 2 ordered pairs here. First one is at negative 4, 0. And the second one is at positive 1, 0. Need a pencil? Got one? A little more points than usual, but those are the 2 that actually matter for the most part. We'll see as we move on. It is dashed. And it's greater than, and the key point is greater than the vertex. So you're gonna shade outside or inside, you're gonna be greater than the vertex.
Inside.
On the interior, inside. And that's the easiest one of these that you'll never see asked of you.
All right.
Any questions on that? That's the gist of it. Find a vertex, find x-intercepts, stuff we've been doing. Before we do the next one of your notes, we'll scan on down to the on the bottom left-hand corner. In the great state of Tennessee, I doubt 25% of the population could get this question right. Student population that is actually currently in Algebra 2. It's that bad. All right, graph of function is shown. Use the graph to determine A, where f of x is greater than 0. Jordan, what do we mean by f of x? What's it fancy for? Y, that's right. Given to us by Donald.
I'm so glad you can read mine.
Y is greater than 0. This is asking what values of x make y greater than 0. Notice the emphasis on values because it's an inequality, and inequalities get answered with inequalities. You can't just say something stupid like x is negative 2. It doesn't even work. Visually, that happens on two tails of the quadratic, here and here. Because anywhere on those tails, what do you know about y? Greater than 0. Now you just have to answer it as an inequality. Talk about that left tail. What is x's relationship to negative 2?
Greater than.
No, the left tail it's not. X is not greater than negative 2 on the left tail. It's less 10. That left tail is moving what direction? Left. Look at it, kids. It's going slightly left, isn't it? If x was negative 4, wouldn't the graph be way up here? If x was negative 10, wouldn't the graph be way up there somewhere? Is y bigger than 0? That's why I said only 4 kids if I miss this question. And I realize it's a difficult question for a lot of kids, but x is less than negative 2. That handles the left tail. But this quadratic has a left tail and has a right tail. On the right tail, your critical value is at 4. You see that? Where you cross the x-axis? I think it's at 4, isn't it? Yeah, it's at 4. What's your relationship to 4? If the graph is moving right as it grows, x is greater than 4. All right, reason 6,533 to hate this class. Interval form. How do you rewrite x is less than negative 2 as an equivalent interval? Like you all go home and do lots of drugs and come back stupid every Monday.
Is it right shooter negative?
Nope.
It's right here.
There we go. Straight shooter himself, Cameron. Negative infinity to negative 2.
Oh, you have to do two.
What's the notation for or?
It's a union.
Union with? It can be bigger than 4. Or to infinity. Mondays, man. Try teaching this all day to a whole bunch of kids experiencing Monday. A looks exactly like D for the most part. What's the difference? Equal to. On a standardized test, simply understanding notation gets you down to 50-50 on questions like this. Because if I made this question, if this is all I asked a kid, one of the answers would have this, one of the answer choices would have this notation on it. And you'd get picked like crazy. So let's look at A and D. Instead of having x is less than negative 2, what do we have?
Less than or equal to.
Less than or equal. Instead of having greater than 4, greater or equal to 4. I know some of you smart people are like, nobody picked that. Yes, they would. Lots of kids would pick that. You pick it. Good. What's the interval for x is less than or equal to -2?
Negative infinity, parentheses, and then -2 bracket.
We're just so crazy. I feel that yawn deep in my soul. How about for greater than or equal to 4? 4, 2, good. All right, B and C look a lot alike, so we'll do that next. You want to do B or C? Doesn't matter. B is fine. B is talking about where is y less than 0. Hopefully you understand that. Where is y less than 0? You can write a note on that, you might should. Visually, that happens there. Anywhere along that path, right? Now you have to define that path. You have to tell somebody the x values that make this true. You can tell me the start and stop x values. It starts when x has a value of what? What's the left x value? What's the right x value? And x is stuck in between them. What is x's relationship to -2? Greater than, but also less than 4. On your graphing quizzes, that domain is killing y'all. Hurry up and figure out domain. A lot of you are confusing x's and y's all the time. We're talking about x's here, nothing more. What's that look like as an interval? I can't hear you. -2? Nope. 4? There's a little more to it than that. Parentheses on both of them. That reads all x values between -2 and 4, non-inclusive. All right. So on C, instead of having -2 less than x less than 4, what do you got?
-2 less than or equal to less. X is greater than or equal to -2 and it's less than or equal to 4.
-2 less than or equal to x less than or equal to 4. What's our interval?
Same thing with brackets.
Same thing with brackets. All right, so that's how you answer inequalities with graphs. So now let's go back and do the one that wants you to answer it by graphing. So solve this one by graphing. How's it open? Actually, let's put it in standard form first. Got to subtract the 7. I actually want to save some steps on this one and not do all the work. How's it open? Open up or down? Opens up. The vertex is kind of optional when you're solving by graphing. It really is. Sometimes you need it, but it's kind of optional. What's not optional is x-intercepts. So I'm going to save some time. We're going to avoid doing opposite b over 2a. You okay with that? Factor that thing. That sounds good to me, Jordan. +7 - 1 Because if you do the inside, you get 7x. If you do the outside, you get negative x. And 7x minus x is 6x. So it's right. Still greater than or equal to 0. Where are your x-intercepts? And again, I'm going to switch over doing that with ordered pairs now because too many kids are taking negative 7, 1 and throwing it as a single ordered pair. Half my juniors did that. Missed question number 5 because of it. So I'm going to throw the 0 in from now on. Negative 7, 0. What's the other one? 1, 0. I've got an x-intercept at negative 7, 0. Closed hole, 1, 0, closed hole. You know it opens up, right?
Yeah.
You guys understand why, right? Because x squared was what? Nobody cares where the vertex is. They really don't. It's actually off the grid anyways. This is why the reason we only care about this is because of that right there. We only care where the graph is what? Above.
Greater than or equal to 0.
That's all we care about. Nobody cares about the rest of it. Just like that last example I did, that's on that path and that path. Would the location of the vertex change those paths? Might change the direction a little bit, but who cares about that? Still going to be moving left, moving right. So we need to answer this. There's an x value, it's at negative 7. The graph is moving left forever. What's your relationship to negative 7? Less than. Right here, the graph is moving left. Everything stays true. X is less than or equal to negative 7. On the right-hand side, the x value is 1 and the graph is moving right. What's the relationship? And again, reason 6,537, you need algebra 2, interval form.
Negative 3, parentheses, negative 7 bracket.
Union with.
1 or bracket 1.
One of those on your test, by the way, if you look at the twin. No. You're not taking me for this year, you're taking me for next year. If you actually listen and pay attention to me, you'll make an A next year in dual enrollment. If you don't, you won't. All right, so that was graphically. Here's algebraically. And there's how you do it. You put it in good old STD form. What's that thing look like in STD form? Bracket 4. I make a direct comparison to 0 now. Oops. Says you can find your critical values by either factoring or using the quadratic formula.
What are your x's?
You got to find critical values, your x's.
So save the factors.
See the factors. Factors is way quicker than quadratic formula. Supposed to be. Let's take to make it 2x squared.
2x and x.
I know a lot of y'all like contemplate the meaning of life when you factor. Just pick up your pencil and write. It'll be a lot quicker than not. The goal is to add to
Make it negative
7.
Negative 2x plus 1, x minus 4.
That'll work. 2x plus 1, x minus 4. Notice I call these critical values. I actually legit cannot say x equals here. Why not?
It's an inequality.
It's an inequality. It doesn't have equality in it, does it? These are actually called critical values. They're not x's, they're x critical values. I always call them x subscript c. Whatever you want.
You still do it like.
You still do the zero product property, kids. If 2x minus 1, or sorry, 2x plus 1 could equal 0, what would it be? Negative 1/2. Even though it can. Another reason why we rename them. If x minus 4 could be 0, it'd be 4. When you plot those on a number line. Notice the open circles? You know why the open circles are there?
No, because
Because it doesn't have equality. 3 says visualize solutions on a number line, and so we did. 4 says test values, your number line should work. I'm going to extrapolate on that, give you a better idea what that means. What you're going to do is you're going to test around your critical values and look for true statements. So one of the first things I'm going to do is I'm going to test a negative 1. Because it's to the right, to the left of a critical value. You see that? Is negative 1 to the left of a critical value? Okay, so if the result is true, I will accept all values to the left of negative 1/2. I do this because I've done this enough times to know that it doesn't matter what you plug in, if it's to the left of negative 1/2 and it's true, everything else is true. You only got to pick one number in each direction. If it passes, they all pass. Or we can spend 30 minutes plugging in a whole bunch of random numbers. We're only going to plug into one number. I personally would go back to the original equation because it's usually easier to go back to the original equation. There's just less stuff to plug into. And I'm making a comparison to 4. Of course it's true. You get 9, don't you? So 9 is greater than 4. This is true, except all values left of negative 1/2. So back in August, when you still enjoyed this class, we were doing this right here. And this is probably the beginning of disgust. Because we were doing 7th grade math. What's that left arrow suggesting you an acceptable inequality would be?
What did you say?
What's that left arrow suggesting the equivalent inequality would be? Is less than negative 1/2. All right, so I tested negative 1. What's something else you should test? We can do that, but you should also test something between. We need to test between critical values. Even easier. There's a number that's easier to test than 1 or 2. 0. Most of you can do that in your head. I hope all of you can do that in your head. What's twice a 0 squared? Take away 7 zeros. It's always been 0. If you can't do that, pay close attention to commandment 9. Accept it as the gospel truth. True or false?
False.
False. So what are we going to do with all the values between negative 1/2 and 4? Accept them or reject them? Reject all values between negative 1/2 and 4. And you could have plugged in any number in there. I hope you get that. Any number would have generated a false statement. So none of this crap matters at all. And the last thing to do is something you already suggested. Test right. So we're going to test right of 4. What's a good number to test right of 4? 5. I realize that this is not the most exciting thing to do. I get it. I do see these show up on the ACT every once in a while. It's like 15, right? True or false? True. So I accept the right tail. It's not hard though. It's like really easy. Now, what's the inequality for that right tail? X is greater than 4. We're almost done, except we got to write it out as an interval. Don't worry, after this you get to use your calculator. I'm good with that. And now you all need a TI-84, including Alan, Jordan, Micah. Oh, you do? Okay, sorry, Jordan.
It was already.
Everybody needs TI-84. I don't care what your last name is, and I don't care what you smell like. You need a TI-84. Sawyers, you got a TI-84? You need one. Yes, the rocket equations. The actual goal of this one is to solve an inequality using the TI-84. Do you know why I don't let you use calculators on your graphing quizzes? There's a y equals button, right? You know how stupid you are for missing graphing questions on tests when you're allowed to use a calculator? Stupid, because what do you see on that thing? Y equals. What?
This is, I don't know.
There's a y equals button, you know? So on those tests where there's been a graphing problem, the whole time, sitting there right in front of your face, the y equals button, kids. It's funny how you forget that. Does everybody remember their first guess? Except for those of you that haven't had one yet. Of course you do. But you don't remember the first time you pressed y equals?
Just now.
No, you did it in Miss Garner's room.
I'm sure I did.
Right underneath the screen. Blue line says stat plot, and then there's y equals, but we don't have an equation yet. So all rocket problems can be modeled by height as a function of time is negative 16 t squared plus v0. What's v0 shorthand for? Velocity plus h0, which is short for initial height. So a rocket is fired with a velocity of 500 foot per second. Where's that going to go? Where the v is, v for velocity. It's not that hard. We don't have a t on that thing, we have x's, so let's write it as negative 1600, negative 16x squared plus 500x plus initial height, 20. So the first question up here is to find the maximum height of the rocket. We'll let our graphing calculator do a lot of work, but that doesn't mean we just type in an equation, we're done. I wish it was that easy. Go to y equals. It is the first button on the left, right underneath the screen. Press it, and you'll see something that looks like that. Then type the equation is, you have to use the negative key, not the minus key. It has to be negative 16x squared. You want to square something, you got a square key there, or you got a rooftop underneath clear. Either one of them works. And don't do anything yet. Don't you hit the graph key. Don't do it. When you're in Miss Garner's room, everything you did was available just by hitting graph. But everything we do in here, you have to learn how to play with a window. This is your first example playing with a window. Always, always, always hit zoom 6. The standard window. So always, always, always hit zoom 6.
Press enter.
Yeah, once you hit zoom and scroll down to 6, press enter. And you're gonna see nothing.
Hey, one of my lines turned blue.
You actually saw a blue line?
Yeah.
Oh, yeah, you guys have the color editions, don't you? Yeah, I don't have that.
They were cool.
I have the black and white version. So you guys did see a blue line, right? Why is that all you see?
Because it's the axis.
Where's the y-intercept of this equation?
Except at 0, 20.
Y-intercept is 20. Count, how far does the y-axis go? Yeah, you can see, no, on your calculator,
Oh.
You can see up to 10.
you can see up to 10. This rocket is being shot at 500 foot per second. After a second has passed, how many feet in the air will it be? 520. Then gravity starts slowing it down. But by the end of the second, it should be at 1,004 foot or so. This thing is going straight up, isn't it? You're gonna have to look pretty high up in the sky to see this. So hit the window button. And you'll see a whole bunch of stuff here that you can overtype. You've got X-min, X-max, X-scale, Y-max, Y-min, Y-scale, some other stuff in there. What do you think enables you to look up?
X,
X-max.
X would look left and right.
Y max or Y max.
Y is high. Isn't it? Isn't Y height? So scroll down to Y max. Don't overtype anything else. Just scroll down to Y max. Make up a number. 2 won't work.
Chris.
After the first second, it's already 500 some foot in the sky.
700.
30.
Okay, 700.
Chris being away.
And then hit the graph key. After you play with the window, hit the graph key. And 700 was just a number he made up. Okay? You'll start seeing more and more of the graph as you keep playing with the numbers. Now, I would like to see where the rocket goes all the way up and where the rocket comes down. Am I gonna have to keep looking up?
Yes.
No, you gotta look down.
No, I gotta keep looking up. The thing is gonna go up and then it's gonna come down. How many foot in a mile?
5,
5, 6, 8, 7 or something? 5, 6, 7, 2?
0, 5.
You know, to get a green card, they make you memorize this. You should memorize this. 5280.
5280. I knew that.
Change your Y max to a mile high, 5280. Hit graph.
Yeah, we still don't see it.
You see enough. Is that thing about to slow down in height?
Yes.
There's no way it's gonna catch up to a mile high. To see the rest of this graph, how many seconds in the future do you think you need to look? 6. It's already at 10. Try 30. To look right is what I'm talking about. X max, and Blue said 30 seconds, so let's try 30. X max to 30, back to graph. Almost. I haven't seen the rocket crash yet.
40.
40.
40, 35 will probably do it. 40 will for sure.
35.
Let's just do 40 because I know that one works. Now you see the entire path of the rocket. You see how high it goes up. You can see when it smashes into the ground. Okay? Now, part A is find the maximum height of the rocket. Its second trace.
Second trace.
Fourth on the right under the screen. Obviously, 4 for maximum. That's what you want, isn't it?
Yeah.
The one at minimum, what would you choose?
Minimum.
Now, when you do that, it's going to say up, it'll say left boundary. Does everybody have a little blinky cursor there real close to the vertex? Okay, and down beneath that, you see the current X and Y values. Those are not necessarily correct. Take your little cursor, get it to the left of the vertex, like it wants. It wants a left boundary. Press enter. You guys will see some horizontal, vertical lines show up on yours. And then it says, what's the right boundary? Take your little cursor, move it right, and once you get it right, it doesn't matter how far right you are, Press enter. And what does it want now? Yes. Press enter.
15.62500.
I get that.
You got 15.6249.
Okay, I know.
I got what you got.
I can speak. Calculator uses a technique called Newton's method, which can take calculus you'll learn. It is going to, on some of our calculators, have differing numbers on x. They're going to be really, really close though, aren't they? They will always get the y value correct. So it turns out it's 15.625 seconds. That's when it happens. 15.625 seconds is the time. But this wasn't even asking about time. This is saying what is the height?
3926.25.
Height is y. Good, we got through part one. That's enough. Let's start shooting go. So when we come back on Wednesday, we'll either fire off a rocket or I'll come up with a problem where something dies.
Either way, I want to try.
Reminders, got a youth coalition meeting this afternoon.